my name's John Murray. I'm founder of a company called Spatial AI, but I'm also visiting professor in the Geographic Data Science Lab at the University of Liverpool. Our lab specializes in data science with a geospatial theme, and we work with a lot of organizations, both in government and in the private sector. We have collaborations globally with other universities. We offer an MSc and PhD program in geographic data science, and it's been running for 6 years now. It's been very successful. Our graduates are snapped up. They're never waiting long. They're usually spoilt for choice. So do look us up as well if you're thinking of going into that field. I'm going to talk about open data revisited. As Julian said, in 2014, I gave a presentation then. At that point, open data was in its infancy. Anyway, so I'm going to come back, look at what's happened since. So my alternative talk title is The Good, the Bad, and the Ugly, followed by a case study. What I say in this talk is my personal opinion. I want to put that as a disclaimer. It is not the views of the university nor any other organization with which I'm associated. So just to recap where we were in 2014, open data was relatively new, probably about 2012. It became very much a government agenda and it started. There was limited spatial data coming out. It was quite limited. Ordnance Survey did some maps and some spatial data. ONS had their boundaries. You've got Land Registry producing some, but it wasn't fully open, which is something I'll talk about later in the presentation. We have ONS data, which has been kind of open data-ish for quite some time, and other national statistics. And you had tabular data from ONS, VOA, Department of Transport, DWP, health providers, both national and local, and many other government organizations. So let's look at the good. So what has happened since that I would actually praise? So this is something which started in 2020. It's the Ordnance Survey Data Hub. Ordnance Survey opened up a lot more of their data in 2020 as a result of the Geospatial Commission. The government set up the Geospatial Commission because it recognizes that geospatial data is good for the economy. It crosses so many areas: utilities, transport, particular infrastructure, demography, so many applications that it's so important. And climate change is something where spatial data is really important. So we have this view. These are just some examples. They're not the only examples, but I've highlighted some examples of open data. So when OS opened up their data, one of the things that they did was the UPRN, the Unique Property Reference Number. And this is the coordinates of every property in the UK, in Great Britain. It's a point, and that obviously you can see in that image there are quite a number of points within one building. Each flat would have a UPRN. Actually, a post box has a UPRN, a phone booth, an electricity substation. Anything that's kind of an infrastructure object or kind of a property, anything that's sort of has either council tax or business rates associated with it will have a UPRN. So these are open. So these are open with their coordinates, and you can map them in geospatial packages such as QGIS or ARC. And this really big development, and there are link tables, so I'll come on to that. TOID is the associated with UPRN. TOID, actually topographical ID is what it stands for, is actually the physical object. So it actually is the coordinates of the physical object. So the building outline will have a TOID. So it gives you the centroid of that. And there is then open roads, which you can actually map the roadwork. And this is routable. So what that means is it is continuous under bridges. So you can actually do routing from this. So you can actually run graph analytics and work out the shortest or fastest route from A to B. So linked identifiers is what brings it all together. So that these are sets of tables that define the relationships, such as the UPRN to TOID. TOID to UPRN is a one-to-many relationship. So there'll be one TOID, which is the physical building outline, connected to several UPRNs if it's flats. Often it's a one-to-one relationship, but in the case of flats, it will be one-to-many. This is one of the best. It's a really good website. It's very clear. The documentation is excellent. It's easy to download. And there's also supported by an API. So you can automate the downloads if you want. You can also create your own, with using the API, your own OS maps with open data to plug into your own applications. And they're completely, unlike Google Maps, these are unencumbered by any license restrictions because they're open data. You can, also in the open data pool, you can pay a premium and you can access some premium data as well. And certainly you can actually get £1,000 worth of credit on the premium data free every month under the new thing, although there are restrictions on its use. So another one I'd like to highlight it did exist in 2014, but it's been largely redeveloped since then, is the Office of National Statistics Geography portal, the ONS Geo portal. This is excellent. This has so many files. And again, it is supported by an API at the back, so you can go and automate your downloads with scripts, which is very important if you're actually wanting to run things on a scheduled task. So because these are regularly updated, you can set up scripts that are run on cron jobs, as it were, scheduled tasks to go and collect data, process it, and make it available. This is really good. So an example there is, if you go and look at, this is a very relevant one because the first results of the 2021 census are due out at the end of this week. So we'll actually be relying on census output areas, which is the smallest area that they report at. So you can actually do some mapping. So census output areas is a very relevant one at the moment. And that's what it looks like when you go into the area, and you can then set up a download, or you can actually, again, through the API, you don't need to download it. You can actually run it as a web mapping service. You can plug it into your own applications. This is one of the best applications of open data that's happened. You heard from Claire Griffiths on Monday. I mean, Claire's team worked so hard on this, but what this did was expose open data to the public. It actually brought it to the masses. So this was used by the public, by the media in particular. So this is a very high profile, and it's well designed. You've got very good summaries. So you've got mapping, you've got detailed information if you want it. You can go in if you want to do your own analysis and drill down or join it with ONS data sets, as you can see on there, and it fully fits the ONS geography hierarchy. You can go and download for regions and your own metrics. So I mean, really, this is a showcase example of what open data is and what it can do. Yes, it was an emergency situation, but I think the lessons from this can be taken forward, which is, it's always been a debate. How do you get more engagement with open data for less technical audiences? And I think this is a really good example of that. So I hope that other organizations will learn from this and adopt this approach in their own data. Another excellent one, in 2016, DEFRA decided to open up, it was one of the most significant open data releases today, all of their LiDAR surveys. Now, LiDARs are very significant. I'll show you an example of LiDAR in a minute, but the DEFRA services platform lets you get access to the LiDAR data, their aerial surveys, bathymetry, so they're measuring water depth. They've got pollution, water pollution. They've got all of the food sort of tariff data. It's a huge platform. It really is very good. So this is what you're presented with. You've got a map interface if you want to go and take some data for your own area. And you can go and just download some, this is looking at my area, Chester, what data is available. So what I'm going to do is just temporarily switch to another screen. So this is, it may take a little while to load because of bandwidth. This is LiDAR data. So LiDAR is points, that's why you can see it very pixelized, but this is a 3D view of Chester. But what I've done here is taken LiDAR data and one of the Environment Agency's aerial photographs from the DEFRA data portal and join the two together. Essentially, I've draped the photo over the LiDAR and then visualized it. So you can actually see the world in 3D, in color. So this is one of the really powerful things. LiDAR is just such a great asset. And one of the areas it's being used, several areas. One, you can see south-facing roofs, for example. So you can target properties suitable for solar panels. Insurance companies are using it to measure properties. You can do approximate virtual surveys with it. You can measure the footprint. You can measure the roof shape, the roof angle from the buildings in LiDAR without actually having to physically see it. So it is a real 3D. You can even, and I've done this, 3D print it. So the 3D printing will actually show you, you can actually put it onto a 3D printer and make this as something you can physically hold. And so that's, LiDAR is just a superb asset. It's also available in Wales and in Scotland, although it's a lot, it's not quite as extensive. So I'm just going to switch back to the presentation screen now. Okay. So I'm back on that. Right. Right. So now the bad. So what is not good? What hasn't happened? Well, the main thing is, despite government initiatives, various promises, address data is still not open. And we have these, when is open data not open data? When it's got restrictions on it. So we have restrictions on use. For example, this is Her Majesty's Land Registry price paid data. It has restrictions because of Royal Mail intellectual property rights in the data. I mean, this is a very contentious point. Does Royal Mail really have a right to declare that it owns addresses? After all, addresses are legacy. If your property is old, local authorities have the responsibility for naming streets and allocating street numbers. Yes, Royal Mail allocate postcodes, but postcodes are just purely for facilitating mail, and postcodes are open actually. So it's one of those things that is, despite noises and the government saying yes, it's spent quite a lot of money. It got the open addresses, and then George Osborne announced money that was being spent on developing a national address register that would be open. It's still not there. You can do bits of it because the Ordnance Survey data, you can join it together and you can make kind of addresses, but they're basically geospatial, but they're not actually correct postal addresses. The other one is energy certificates. That's also one. This great data set that's been opened by the communities and Levelling Up, all energy certificate. However, we still have this thing on. However, because it contains UPRNs, you can link it to coordinates. So you can now use this data with the UPRN to attach coordinates. You can ignore the other address fields and you map properties. So you can actually link it to OS data via UPRN, since UPRNs are now opened up. So the ugly, right. So what has happened that's bad, really bad? Right. Withdrawal of OS data sources. OS announced in 2017 that they're going to withdraw a number of data sources as open data. They were without consultation. Once I found out about this, university and others made representations on this. The main problem for us is, yes, they were drawing Meridian and they're saying, well, OS Vector Map District is a suitable replacement. But a particular project we were working on at the time involved the railways. And what we were working on was looking at, there's a semi-disused railway in Cheshire, which goes from Northwich to Crewe. It's called the Middlewich line. And we were asked to look at the economic and the social case for reopening that line to passenger services. And because although there is a rail lines are in Vector Map District, they're not routable. And I'll show you what I mean by that. So this is looking at Chester. So this is Vector Map District with all the layers on it. So you can see Chester there, you can see the rail lines. What happens if I remove all the other layers? Your rail lines are disjoint. The issues are bridges obscure it, but mainly you've got the station and the station partially obscures it. Now, the problem there is you can see various lines going in the center of it where the station is, but are they through platforms or they're under the canopy? Are they through platforms or are they terminal bays? So is this so we've no idea. We can't tell which way the points go. So, for example, there's a bridge there that's obscuring points. So we're not able to create a routable network anymore. This would fail if you put this into a graph package to find the shortest path. We still have the old data which we can use, but it is not updated to reflect any changes to the rail network. And it is one of the things we've been working very closely with Northern Rail and some of the local community partnerships. We've had some students seconded to working on some of these reopening projects and helping to build the economic case. So that's one of the ugly things, is withdrawal of data sources without consultation. Even worse is data that was previously released under an open government license, OGL, it's still published, but they've withdrawn the OGL. And the Valuation Office Agency did exactly that. And they retrospectively applied it. So it now has restrictive terms and conditions. So you actually can, I understand the reasons for it, that they were saying that some unscrupulous people were using it for direct marketing, but that can be dealt with because within the data, the ICO is quite clear that even if data is in the public domain, using it for direct marketing, it's not fair game unless you've got the consent. So it does not make it usable. But so it was enforceable under data protection anyway, but they went ahead. Now, it caused us, again, problems at the university because they not only withdrew the registers, they also withdrew the aggregates. Now, we did make representations, as did other universities, and I'm pleased to say they did reinstate the aggregate data. So they do give stocks of properties at census output area, because it's very important. One of the areas we work with in the Geographic Data Science Lab is we've been working with the government on helping to redevelop high streets. So we need to know the stock of retail properties. What's the how many square meters of retail property is available? What type of properties are available? And then you've got council tax. You can see your property stock. So these are very important data sets for research. This is one that I would include in that. it's one of those that I would say was a double-edged sword. A high-profile court case between a small company called 77M Limited and Ordnance Survey. It came about over actually the T's and C's involved in open data. Now, the land registry polygons, there was a restrictive covenant initially on them that said you couldn't republish the geographies. So then it came that there was then a further restrictive covenant that was breached. So you couldn't actually create any product. So this went to court, and actually there was a bit of both sides won on this. So it was that you can use, it was not an infringement of database right to use the INSPIRE polygons. If you derive, say, example, the area of a polygon, that's not giving away the coordinates. It's derived from the coordinates, but one of the things the judge did do was clear up what classifies as derived data. And the actual outcome of this is OS opened up this data. So this is now open data. So it kind of took a court case to get something that should have been open data as open data. But it's one of those things that happened. It dragged on for quite some time. And indeed, I would say it held back developments while the court case was ongoing. OS did win some of the parts in that if you acquire open data outside the T's and C's, it's not licensed. For example, if their T's and C's say you must not scrape this web page, and you scrape the web page, you have not acquired it legally, and therefore you have not acquired a license, and therefore your use is unlicensed. So you only acquire a license if you download it by permitted means. So this is very important. There's a lot. The judgment is well worth reading if you're suffering from insomnia one day. The other thing, you may wonder why this is in ugly. It's a great resource, the open data portal, data.gov.uk. But it's not always up to date. In fact, it's actually parts of it are horrendously out of date. And it's very much links don't work. Some of the license terms are out of date. Descriptions are out of date. Some data isn't on there that should be. Some data on there is no longer available. So it's one of those things. It's a great idea, but I think the interface is not very good. I think they could do a lot better. And some of the things like OS, near Geopod, there are a lot better products out there that are more intuitive and drill down metadata repositories that could be used for this. So I'm going to finish with a case study. And this is an AI case study. So this is some background. So I recently worked on a paper that I instigated this paper and did the bulk of the technical work on it. The idea was, could you classify neighborhoods demographically, so estimate the demographics of a neighborhood purely from a satellite image and nothing else? So what we did was to build an AI model. Now, this is an interesting type of classification because it's unsupervised. So, I mean, this actually started from a conversation I had at a conference in Munich in 2018. I'd seen this approach applied in autonomous driving, and I thought, could it be applied to this? And the reason is, A, the government is keen to abolish the census, so they're looking for replacements. The satellite data is freely available. It's updated weather depending every few days. So you can keep an eye on it. Really, the hypothesis that we're trying to test here is, does how an area look in a satellite imagery reflect its demographics? So you can actually read our paper. I've linked it there. I'll make these slides available afterwards. I've put a number of links at the end of the slides, and I'll make them available as a PDF. So you can actually follow the links and follow some of the papers. But I just wanted just a very quick overview. So we're looking at multiple coordinate systems. So Ordnance Survey has its own. So the main one that is used by GPS systems and your mobile phone is WGS-84, the World Geodetic System 1984, developed, originally came out of NASA. And so you basically divide the slices, divide the world up into slices. So slices and bands, and they're based on angles. The thing is, the Earth isn't a perfect sphere. It's fatter in the middle, and it has a multiple eccentricities. So it's not as straightforward as doing great circle. It's a little more complicated. So you've also got another coordinate system, which is the Universal Transverse Mercator System, and the MGRS, which is the US Military Grid Reference System. Now, these basically divide the world into zones, so UTM zones we see there. So they're the main grids. And then within each of those, it's subdivided. It's a bit like OS have their grid reference system, but the relevance of using UTM and MGRS is that is how satellite imagery is presented. So both the European Space Agency and NASA publish their satellite imagery using MGRS tiles. So that's actually what you have to go and look up. So we need some conversion. NASA and the European Space Agency, through the Copernicus Sentinel program, publish a lot of open data. It's all freely available. And then we've got the British National Grid, which uses a very out-of-date ellipsoid, which is 200 years old. It has a lot of eccentricity, inaccuracy, and so these have to be corrected for with interpolation of ground reference points. So the maths involved is quite heavy, but we deal with that. So this is just looking at a satellite image of Chester. This is from the Sentinel-2, and we can just see a 10-meter resolution image of Chester. But you've not just, that's just the RGB, the red, green, blue bands. But we can also start looking at the non-visible bands. So this is a near infrared pseudo color. So we can start seeing that. And what we're seeing there is that the near infrared highlights vegetation and water. So what I need to do is then convert the ONS postcode directory, which I suspect quite a lot of you will be familiar with, to be able to be compatible with satellite imagery. So we need UTM coordinates, and we need the MGRS tile. So we have some software that takes ONS PD and it calculates all of those, because what we're going to do is to crop the area around a postcode from the Sentinel satellite imagery. So we actually have the file locations there, and we can use the coordinates to decide where to crop. So I won't go into technical architecture too much because it's outside the scope of this talk, and it's in this, we go into much more detail in the paper, which is linked at the end. But the type of neural network we used is a type called an autoencoder. Now, an autoencoder is a type of neural network that is self-supervising, so self-learning. So basically the input is the same as the output, but what it learns to do is compress the image. It's a bit like JPEG, except you don't tell it how to do it. So we start with a 16 by 16 by 4 pixel channel imagery. So we've got red, green, blue plus infrared. We then put that through and we produce an 8 by 8 by 1 compression of that image. And then that gets, so the model learns to compress and reconstruct the image. What we then do is we cluster that latent representation using just simple k-means, which is a statistical technique for clustering. And that is what we use to then classify neighborhoods. This is unsupervised classification. We ran it in TensorFlow, some of you may be familiar with TensorFlow. So we actually finished up as we run through the epochs. We actually finished with 1,000 epochs, and we were getting about 95% reconstruction accuracy, which showed our neural network was working pretty well. We're looking at the validation, and this is the results applied to Liverpool. So what each dot here is the postcode centroid location. what we've actually asked it to do is we haven't told it how to do it. This is unsupervised. We just said group buildings, group clusters of buildings that look alike. So you can see in the, it's very much, it's separated out the leafy suburbs with the larger houses. The commercial districts are purple in the city centre. You've also got your terraces, which are the light blue. So you've got your densely populated terraces. And as you get further out, you've got the larger houses, which tend to be purple, and you've got some that are kind of in between. It's worked really well. I mean, this is still something that's under development, but it was a proof of concept. But it's actually worked really well. And when we actually started testing this and calibrating against known ONS data, it actually calibrates really well. So it does find deprivation, it does find affluence, but it's very much based on property characteristics. So it's something that we've shared with ONS, and we've got some discussions going, something that's generated a lot of interest, and it's still very much work in progress. Okay, so there's some references there, the papers that link, our paper there is a link earlier in the talk. And finally, these are the links to some of the websites that I've shown you in this talk. Thank you for your time. And now I'll hand back to Julian for questioning.
Right, thank you, John. That was really interesting. It's always good to speak to a practitioner, somebody who's actually been doing it rather than talking about doing it. So it's been really interesting. As mentioned before, if you've got a question for John, if you can type it into the Q&A box, that makes it easy if we can see what questions there are. Also, if there's a question that somebody else has posed, if you can upvote it, then the ones that are most interesting can then trickle to the top. But I'm going to start really with a couple of questions. So the first one really is kind of a hybrid, really, is just be interested in your thoughts, John, comparing sort of the UK's approach to open data and how that compares globally with other approaches. Are we in the lead? Are we behind? And what you think the view is going ahead. If we are behind, are we catching up? If we're ahead, are we going to stay ahead? What are your thoughts?
It's quite a tricky one, because I think we're ahead in some areas, quite a lot of areas in terms of mapping data. But quite a number of countries have their address base. France, I mean, France has had its equivalent of address base for about 10 years now. That's been open data. Australia, the address file is open data. United States has a very interesting policy. They basically don't call it open data, they call it government data work. So basically the idea is, if this government data is government data work, the taxpayer has paid for it to be produced, therefore it's released under a license called government work. So that's an interesting approach. I mean, the US is very, very good. Germany's interesting. They've got BKG, the equivalent of OS. They publish quite a lot of open data and similar to OS. But the problem with a lot, say, LiDAR in Germany, and this applies in quite a few federal countries, is that LiDAR and a lot of other data is at state level, not at country level. So we're actually having to then go to the individual states, and some decide to publish and some don't. So Germany is a bit of a patchwork quilt. France, IGN, which is the equivalent of OS, is now starting. France has just released LiDAR, so they're catching up with us. I think in terms of our environmental data, that's by also I include the Met Office in that. The Met Office is very good at publishing data. The Met Office has published its climate change models, it's published historic weather data, and this is really useful in some of the work some of my colleagues are doing. We're really looking at what's happening with climate change, and you can monitor it. And other countries have done similar, but I think it's a mixed bag. I would say my answer is a mixed bag.
Yeah, thank you, John. And just a quick mention there. So Andy Mabbott has popped up in the chat. Just a quick reminder. So he's doing a talk this afternoon based on OpenStreetMap. and about open addresses. So if you are interested in this topic, then this afternoon session at 4 p.m. Should probably be of value to you. Something else that might be worth going through, and you touched there on the US approach of if it's government funded, it then becomes government works, therefore it's their version of open data. And just thinking about your thoughts about the drivers for open data, but also you mentioned there about the open data portal, how some of the data sets aren't really kept up to date. And that almost implies that in their drivers were, we want to get a checkbox to say, have we published X data? They've done the publishing, they've got the tick in the box, but they've actually don't really believe it has any ongoing value. So what are your thoughts about the drivers for going open?
I think when I sort of was talking about data.gov.uk, I'm more talking about the, if you like, the gateway rather than the open data, because there's a lot of good open data, but it's often at departmental level. So there isn't, I mean, the US does have an equivalent, it's data.gov. It's well worth looking at. The US seems much more joined up. It seems to me that it's a little bit, because it's at departmental level, it seems a little bit fragmented. And it's kind of who's responsible for keeping data.gov.uk, which is basically meant to be all the signposts and the metadata catalog, up to date. I also just noticed, if I may mention this, Andy put in the chat, OGL is irrevocable. I'm interested in that point, because that is VOA. We have had discussions with VOA. They are adamant it can be. So it's a very interesting, again, these sometimes, until these things are tested in court, they can't, I mean, nobody's tested the ownership of address data in court. That would be a very interesting one. So again, it's an interpretation.
Yeah, no, that's interesting. I think Martin actually also raised a very similar question about the OGL sort of being able to keep pace with CC BY. So yeah, no, you've covered that fairly well. Mary Susan's asked a question really in terms of just getting your view, and this isn't so much open data, but it's more general about geospatial data, about the UK withdrawal from the EU Galileo program. So should the UK continue to rely on US GPS data?
Well, I'm not sure, because they're saying one thing. I'm wondering whether there's some political posturing in this. The US data isn't as granular. That's the main. When you speak to rail operators who use it for ETR, MS, you speak to utilities provider, it does not have the same level of granularity that a more dense satellite network does. I think it would be a shame if we withdraw, but that generally, my view on Brexit is we are where we are. We have to make the most of it. I think it would be a shame, but yes, yeah, we will lose a lot by doing so.
So it presents some challenges, but I guess there also is probably a chance for some innovation to maybe bring some other thinking through. So a question from John, which would be could be useful to get your thoughts on, about whether you've got any views on the usefulness or otherwise of the INSPIRE regulations. Now, I don't understand that, but I hope you do.
Yeah. Again, INSPIRE is a EU directive. I mean, UK is still sticking to it. It's about the publication of open data. So we haven't actually seen any changes at the moment. I mean, in terms of INSPIRE, I'd say the UK is ahead of other EU states, many EU states. When you look at cadastral parcels, for example, the land registry polygons, very few have them fully open as the UK does. So I think in terms of the satellite imagery is part of INSPIRE, and that is actually open to us. So even though we have left the EU, anything published by another EU member state under INSPIRE is open data. It can be accessed anywhere in the world. Similarly, US data can be accessed by us as well, and they can access our data. So open data should be without barriers.
Yeah. You mentioned there also about, in terms of data.gov and the various different data sets that are out there. And any thoughts about both the challenges and maybe the solutions around interoperability? How do we make sure all these data sets play nicely together, for want of a better term?
Well, that's that's something that is a bit of a challenge when you've got, as I showed there, different coordinate systems. So you actually have to do some computation, which then takes it out of you can do coordinate conversion in QGIS. You can do it to various levels of precision. It isn't particularly fast when you have a large data set like a satellite imagery, if you do it to high definition. So if you were to use OSTN, the Ordnance Survey Transformation Interpolation Grid, it is quite slow. So we are actually using high performance computing because, for example, a satellite radar manifest, as it's called, just of a tile of the UK, is 500 million points. You won't do that in QGIS, it won't handle it. So sometimes scale of some of the data sets is a bit of a challenge. That's really all I can say on that.
Yeah, but I guess in terms of the geospatial world, you've actually got that reference back to the underlying spatial grid and the coordinate system. But when you start straying into other data sets, maybe population-based data or demographic data, you've lost that reference. So yes, that interoperability challenge starts to become a lot more challenging, really.
Well, actually, with ONS are pretty good at that. So they label things, and the example of the COVID dashboard, it has the ONS area, and you can download those spatial files from the ONS Geo portal. So that's ONS is actually providing a lot of the glue. As I said before, that was one of the things I said in 2014, that spatial data is the glue. ONS has linked identifiers that link census geographies to actually physical geographies, and they actually present it in a hierarchy as well. And Claire's dashboard is a good example. They publish it there using the ONS geography. A lot of data from a lot of government departments is published. So it isn't an issue in the UK. It's also similar in other countries. So in the US, you have census tracts, which are the equivalent of output areas, and a lot of their data is published. They've got the mapping data around it. So it's the interoperability now is a lot better than it was 8 years ago. It still could come some way. You have got, for example, ONS provide a UPRN to postcode lookup. So you can say this postcode contains these UPRNs. Yeah.
Yeah. So I'll just sort of read some views coming through on the chat because they won't come through in the ultimate recording that goes up on YouTube. But Andy's chipped in with some comments talking about the licensing I mentioned earlier about OGL3. The licensor grants you a worldwide royalty-free perpetual non-use exclusive license. So his view was that word perpetual is key. That if a license isn't perpetual, then it's not open. So that's an interesting point there.
But I do agree with Andy. I'm totally with him. I mean, we had these discussions. We are actually saying you can't, if we've already downloaded it, you can't stop us using it. That's the position we took at the university. But unfortunately, Valuation Office Agency did try to an organization which actually was working on publishing sort of supermarket availability, and you heavily relied on the non-domestic rates of property level, did get a cease and desist letter. So it is a sense, we have had a number of skirmishes around the T's and C's. And it's this, there's also overriding that, which is what the 77M case relied on, and what Royal Mail rely on, is that you can say, well, OGL does not include any underlying IPR in the, which is a little bit of a get out of jail free card. But so it's one of those, I think, when it goes to court, or if it goes to court, then we might actually get a definition. And I look forward to Andy's talk.
No, it's going to be interesting, isn't it? Definitely.
Yeah.
So there's been an anonymous question asked, but I think it opens up a really interesting area. Really, is that so? An anonymous attendee asked, really, is what leverage can we use with commercial companies to share their potentially useful data? So, is the example of resistance from the post office typical? Now, I think I'd like to add on to that question. Is I think this gets into a really interesting topic, really, in terms of also security and commercial confidentiality. And so Alex Luck's session tomorrow afternoon is going to touch on some of these issues. But it's really, if you know a data set exists, actually, do you have any power to make an organization publish it as open data? And also, what about the data sets we don't know exist?
Well, I mean, the PAF is kind of an exception in that it was a botch move, which was reflected in a government committee, that when Royal Mail was privatised, PAF should have become the responsibility of Ofcom, because not just that it's Royal Mail, the PAF has to be made available because Royal Mail do not have a monopoly. Therefore, the PAF data set has to be made available to other providers of mail and parcel delivery services. So it would be better to have that as an open resource that is freely available to those organizations as well as end users. But it's a massive mistake. I think opening up the amount of revenue that's got from sales of the PAF, the economic benefit would seriously outweigh it.
Yeah, and I guess it's one of these ones though, in terms of the costs, and one benefit is in one bucket, whereas the benefits, the one is out external organization, and then you get into a whole different societal question. It also probably gets into a philosophy of whether an organization is taking a very narrow commercial focus or maybe potentially a slightly more altruistic focus. So Chloe's session yesterday at TfL took a view of, let's publish a lot of our data feeds that then becomes an ecosystem that is working off those data feeds, but actually also let's create our own products so we understand and can improve the quality of the data. So that balance between having a more altruistic approach to a very closed, purely commercial approach is, it's going to be an interesting tension there.
Yeah, I mean, if an organization's invested, I mean, I have this in my own business. I mean, we at the university, we actually have made all the outputs from our AI model at the case study are all open. Our papers are now open source. You don't have to pay, anyone can access. But we've also made the data and the source code available. But commercially, I can't afford to do that because I could invest in developing something and get no revenue, and that's not a business model that works. So unless a private organization gets sponsorship to make something open, then how do they do it unless they've got a trust?
And so just about the final question we've got in the Q&A panel at the moment, but by all means we've still got time to answer a couple more, so if you've got a question for John, please post it in the Q&A box. So Mary Susan made another comment really about the National Archives being responsible for OGL and copyright, and again this leads in my thinking also is I've got a passion and interest around the long-term sort of preservation of data and taking more of a long-term view. How do we actually make sure that what we're publishing now is going to be fit for the future as well as being available now?
Well, the National Archives does have the government web archive, which is very good, and it's enabled me to go back in time actually, because I did get a question, some open data that I hadn't. So a lot of open data is ephemeral. It's only published for a certain period. So it's only available for a certain length of time. And if you're wanting to do time series, that's a problem. So we actually, for example, a company's house, the basic data product is available for about 3 months. So, but I've actually got it back to May 2012 because I've collected every one. I have an automated script that collects it. So we can actually do, and it's actually been really useful during COVID because within the lab, we've been looking at what the impact of COVID has been on companies. So we can actually look at a time series because it's just a monthly snapshot. It isn't a time series. So we can actually convert it into a time series and track companies right throughout. So we can actually create some economic briefs. I mean, we actually also used it. In the media, we challenged some of the media. A very simple example, the Daily Mail and a few other papers had headlines like company bankruptcies at record high. So what I did was actually say, well, hang on a minute, there are more limited companies now. So if you actually take it as a percentage of limited companies, they're actually less. The number was higher, but the percentage of companies failed was actually falling. So it's about lies, damn lies, and statistics.
Yeah, don't let the facts get in the way of a good argument.
Yeah.
Indeed, yes.